Did you know this? Every year, demolition waste from construction sites accounts for between 300 and 400 million tonnes of waste. Across Europe, that's between 33% and 40% of all waste produced. To tackle this challenge, many companies are working on circular economy solutions. Among them is CEMEX, which is developing new ways to reduce the environmental impact of construction. In this video, we'll take a look at some of the strategies that can help make construction more sustainable. Each year, France produces around 20 million tonnes of concrete. Across Europe, in 2024 alone, production reached nearly 674 million tonnes. But what exactly is inside 1 cubic metre of fresh concrete? On average, it contains 350 kilograms of cement, 1,000 kilograms of gravel, 850 kilograms of sand, and 175 kilograms of water. That's a total of 2,375 kilograms per cubic metre. If we convert that into percentages, we see that 77.42% of the mass comes from aggregates, 15.05% from cement, and 7.53% from water. In other words, more than 3/4 of concrete comes from natural aggregates, usually extracted from quarries or marine dredging, like in Le Havre, France. This highlights an important issue. The concrete industry relies heavily on natural resources, but solutions exist. Let's take a closer look at a concrete production site in Normandy, the CEMEX plant in Anneville-Amberville. Here, materials from demolition and earthworks are recycled and reused. To understand how materials move through this process, the most effective tool is life cycle assessment, also known as LCA. First step, extraction. Raw materials are taken directly from nature. This stage has a significant environmental impact, mainly because construction machinery emits CO2. Second step, transport. Most materials are transported by road, which contributes to greenhouse gas emissions. At the Anneville-Amberville site, however, a river dock allows materials to be transported by waterway, which significantly reduces emissions. River transport can consume far less energy than road transport. Third step, processing. On site, materials are crushed and screened to produce aggregates that meet the European EN 206 standard. A dedicated laboratory monitors quality and durability throughout the process. Steps 4 to 6 include transport, construction, and the service life of the concrete. These stages remain mostly conventional, although manufacturers are exploring electric transport vehicles to reduce emissions. Finally, steps 7 and 8 focus on deconstruction, sorting, and recycling. These stages are becoming increasingly important. Today, concrete used in buildings can include up to 10% recycled aggregates, and this percentage is expected to increase as regulations evolve. This shift will also create new jobs across the sector. The site itself is organised into several areas dedicated to aggregates and concrete production. Technical departments and laboratories B and C monitor the materials. Natural aggregates are stored and processed in areas D and E. A dedicated platform, Area F, handles recycled materials from demolition. Finally, Area G, the ready-mix concrete unit, produces concrete using both natural and recycled aggregates. This setup creates 2 parallel pathways, one for natural materials and another for recycled materials in concrete production. To measure the environmental benefit of recycled aggregates, we focus specifically on their life cycle. Unlike some low-carbon concrete strategies that target cement, the Amberville approach focuses on replacing natural aggregates with recycled ones. The carbon footprint mainly depends on 3 stages. First, deconstruction. Sorting materials during demolition allows millions of tonnes of aggregates to be recovered. Each material, wood, plaster, metal or plastic, enters its own recycling stream. Second, sorting and crushing. These processes take place directly on site, reducing transport needs and ensuring aggregates meet European standards. Third, concrete production. Ready-mix concrete is produced on the same site, currently containing up to 10% recycled aggregates. Trials with 10%, 30%, 50%, and even 100% recycled aggregates are already underway as part of a project in Bordeaux. To illustrate the impact, let's compare 2 identical concretes with the same composition and performance. The only difference is where the aggregates come from. In scenario A, aggregates are extracted from a quarry and transported around 20 kilometers by truck to the concrete plant. This is the most common supply chain today. In scenario B, aggregates come from demolition materials. They're first transported about 5 kilometers by truck to a port, then 30 kilometers by river to the treatment site. There, they are crushed, sorted, and reused. Life cycle assessment shows that river transport significantly reduces the carbon footprint compared with road transport. As a result, recycled concrete emits around 2.13 kilograms of carbon dioxide per cubic meter, compared with 2.41 kilograms of carbon dioxide per cubic meter for concrete made with natural aggregates. At the same time, this approach preserves natural resources by reducing quarry extraction. Of course, we are not yet at 100% recycled aggregates, but this is the direction the industry is moving toward to reduce the environmental impact of concrete construction. Recycled aggregates are more than just a material. They represent a smarter way of managing resources. Construction materials are reused, natural resources are preserved, and transport distances are reduced thanks to local production sites. The result? Fewer trucks, lower carbon dioxide emissions, and controlled costs. And on the ground, it means active recycling platforms, teams who sort, crush, and monitor materials, local jobs, and new skills being developed. So, in summary, modern construction must evolve and pay closer attention to the natural resources it consumes. Thanks to research and life cycle assessment, companies like CEMEX are already developing solutions to reduce the environmental impact of construction. And this is only part of the picture. Other innovations, such as low-carbon cement, are also being developed. All of this shows that the industry is moving in the right direction. We can be confident the construction and civil engineering sectors are actively working toward a more sustainable future.